The collection head was already overflowing. That was the first sign that NASA's asteroid mission had entered its most critical phase. Not while reaching Bennu, not while touching its surface, but only after the spacecraft had already accomplished the task it had spent years preparing to perform. For 6 brief seconds, a robotic arm reached down toward a small crater on asteroid Bennu. Compressed nitrogen burst into the loose surface, lifting ancient fragments into a circular collection head designed to trap at least a modest amount of material from one of the oldest objects in the solar system. Then the spacecraft fired its thrusters and backed away. Everything appeared to unfold exactly as planned. At first, no one knew just how successful the maneuver had been. The collection head remained extended at the end of the spacecraft's arm as images slowly crossed millions of kilometers toward Earth. Engineers expected days of careful analysis before estimating how much material had actually been captured. The mission timeline still included a carefully planned sequence of measurements, including a gentle spin that would reveal the sample's mass by measuring the spacecraft's changing inertia. Instead, the first photographs revealed a very different problem. Tiny particles drifted away from the collection head, moving slowly against the darkness of space. They were not supposed to be there. At first glance, the escaping grains seemed almost insignificant, a few bright specks catching the sunlight, small enough that they might have gone unnoticed if the cameras had been pointed somewhere else. But they kept appearing. Each new image showed more fragments surrounding the collector. Something inside the mechanism was no longer fully sealed. A different camera angle finally explained why. Large pieces of asteroid rock had become wedged inside the entrance of the collection head. Flexible mylar flaps, designed to swing shut after material entered, remained slightly open. They had not broken. They simply could not close because the spacecraft had gathered far more material than the mechanism had ever been expected to contain. The mission had succeeded beyond its own engineering assumptions. That success was now drifting away, grain by grain, into empty space. Only days earlier, Bennu had appeared to be a solid destination. When the robotic arm touched its surface on October 20th, 2020, reality proved stranger. Instead of meeting firm resistance, the collector plunged roughly half a meter into an unexpectedly loose rubble pile. Scientists later compared the behavior to stepping into a container filled with plastic balls, rather than striking solid rock. The nitrogen burst stirred up far more regolith than anyone had predicted. Small dust grains entered the collector. So did larger stones, enough to prevent the sealing flaps from performing the one job they had been designed to do. From that moment on, every movement of the spacecraft carried a consequence. Routine flight operations suddenly became a source of risk. The planned spin maneuver, originally intended to answer one simple question, how much had been collected, would rotate the spacecraft just enough for inertia to fling additional material through the opening. The very test designed to measure success threatened to reduce it. Mission managers faced an unusual choice: gather better information, or protect what they already had. The decision came quickly. The spin was cancelled. No one would know the exact mass of the sample until years later, after the capsule returned to Earth. Accepting that uncertainty was preferable to watching irreplaceable material continue drifting away during a routine maneuver. The mission's objective changed. Collecting Bennu was no longer the challenge. Keeping Bennu became the challenge. Attention shifted to the sample return capsule waiting inside the spacecraft. The collector head would have to be placed inside it and sealed days earlier than originally planned. Procedures written for a deliberate sequence of checks were rewritten into an accelerated containment operation. Nothing about the task became physically faster. Instead, Every movement demanded even greater patience. The robotic arm had to guide an overflowing collection head toward a narrow opening inside the spacecraft, while controllers on Earth worked through the unavoidable communication delay of deep space. Commands traveled outward, images returned later. Every adjustment depended on photographs taken after the previous commands had already been carried out. The engineers never watched the operation unfold in real time. They reconstructed it one delayed image at a time. Meanwhile, particles continued to drift away whenever the spacecraft changed its orientation. Each fragment represented material that had survived since the formation of the solar system more than 4 billion years ago. Once it escaped, it was gone forever. Several days ahead of schedule, the stow sequence began. Slowly, the collector head disappeared into the waiting capsule. Mechanical latches engaged. Telemetry confirmed each step. Then, the final signal arrived. The capsule was closed. The drifting particles stopped. For the first time since the leak had been discovered, the collected material was no longer exposed to space. Even then, one question remained unanswered. No one actually knew how much of Bennu had made it safely into the capsule. Without the cancelled spin test, there was no reliable measurement. The spacecraft departed for Earth, carrying an unknown scientific treasure locked behind its heat shield. That uncertainty remained for nearly 3 years as the capsule crossed interplanetary space. Only after the return capsule landed on Earth in September 2023 did the answer emerge. 121.6 grams. More than double the mission's original requirement of 60 grams. The overflowing collection head that had forced NASA to abandon its own verification procedure had still delivered one of the richest asteroid samples ever returned to Earth. By then, the object that had once hovered at the end of a robotic arm no longer looked like a collector. It rested inside a sealed return capsule, and later inside a clean laboratory, surrounded by trays of dark Bennu fragments that had survived both abundance and escape.